In this video, I'm going to be completing the parallel lines cut by a transversal notes. Parallel lines are lines that are on a plane, and these lines will never intersect. As a quick review, a plane is a flat surface. All right, so I'm going to start by highlighting my two parallel lines, and I'm also going to shade between these lines. The reason for that we will see in just a moment. Okay. A transversal is a line that intersects two or more lines. And my example of a transversal is right here. Corresponding angles share the same location and they have a congruent relationship. And as a reminder, this equal sign with a squiggly on top is our congruent symbol. So there are four pairs of corresponding angles, and we're going to start by looking at angle number 1. Okay, we have our angle 1 here, and it's in the top right corner of our intersection. So I treat these like they're two roads, two intersections, so Plum and 67th and Quivira and 67th. I see that my angle 1, my first car, is in the top right position of that intersection. So if I look below that, the car that is also in the top right position is 5. Okay, I can look at my car number 2, which is in the top left position. And if I find the car in my other intersection in the top left position, I find angle 6. I can repeat this process for 3 and 7 and 4 and 8. We also have 4 other angle pairs. The first 2 are alternate angles, and we're going to have a pair on the inside and the outside. Alternate interior angles are inside the parallel line, so they both fall in that shaded region, whereas the exterior will be outside the shaded region. Alternate angles are going to be on opposite sides of our transversal. And all pairs of alternate angles are going to be equal to each other or congruent. Let's go ahead and look at our examples of alternate angles down here in this box. So if I shade between my two parallel lines, and then I trace my transversal, I'm going to start by looking at my angles that are on the outside. So if I start here, I have angles 1 and angles 2 in my top intersection that are both on the outside. And now I want to ask myself, on the other intersection, here, I'm still looking outside the shaded region, okay? Which angle is on the opposite side of 1? So between these two, if 1 is on the right side, I want to look on the left side, and that gives me angle 7. Okay, I'm going to do the same thing with 2, and what I'm left with is that angle 8. You do the same process with your interior angles. Okay, now since we're looking on the inside, I'm going to be looking at angles 3 and 4. And when I'm looking on the inside, so the shaded region of this bottom intersection between my car 6 and my car 5 is on the right side, which is the opposite of 3. Okay, now I can do the same thing. So I have angle 4, and I want to know which angle is on the opposite side between 6 and 5, and that is 6. Now we're going to look at our same side angles. So we have interior and exterior again. Interior is inside my shaded space, and exterior is on the outside, my unshaded space. Okay, but this time we're going to have angles that are on the same side of the transversal. These angles have a supplementary relationship, which means that they're going to add up to equal 180. Okay, so we're going to come back over here again with our same side, but now we're going to be looking at the same side. I'm going to shade the inside between my two parallel lines, and you'll see I'll do that every single time to help me visualize where I'm looking. And then I'm looking at angle 1 first, and I want to see which angle between 7 and 8 is on the same side, is on the same side of my transversal, the same side of that orange line. And between 7 and 8, that's going to be number 8. Okay, my angle 2 is the other car that's on the outside. And if I look at my two cars that are on the outside of my other intersection, if 2 is on the left, the other angle that's also on the left is angle 7. Just like before, we can identify this same side relationship, but on the inside. So if we're looking at angle 3 on the inside, I'm going to jump down to my other intersection. I want to look at just 6 and 5 because I'm looking inside my two angles. And what I see is that needs to be angle 6. My other angle that I have left to look at is angle 4. And my remaining car that's on the inside is 5, which is to the right of the transversal, just like 4. We can use these angle relationships to solve for missing values. And so I'm going to start by shading my image here. And I'm going to use this to first identify what the name of my angle pair is. I see that my question mark, my missing value, is outside of my parallel lines. Okay, and then I have my 132 degrees. I see that these are both on the outside of that shaded region, so I'm looking at exterior pairs. And they're on opposite sides of that transversal. This car here is on the left side, this car is on the right side. So I have alternate exterior angles. You can refer to the page before, which tells us that our alternate exterior angles have a congruent relationship. So if I set up an equation, I'm going to put my question mark, my missing value, and I'm going to set it equal to 132, which means that my missing angle, it's already solved for, it's 132 degrees. We can do the same thing with our number 2. So I'm going to start by shading. And when I do that, I see that I have two angles that are both on the inside. They're in that shaded region, and they're both to the right of this transversal. So they are same side interior. Same side interior angles are supplementary, which means they're going to add to equal 180. So I'm going to set up my equation. I know that my question mark and 78 is going to equal 180. In order to find that missing value, I'm going to remove 78 from the total degrees, 180, and I'm left with 102 degrees. All right, here we're going to have a more involved process. I'm going to start by still highlighting. All right, and I'm going to mark my angles. I have this 14x and this 10 plus 13x. I see they're both in the shaded region, and then my 14x is to the left of my orange line, and my 10 plus 13x is to the right, which makes them alternate interior. Alternate interior angles have a congruent relationship, so when I set my equation up, I'm going to set these two expressions equal to each other. And now I'm ready to start solving my equation. I'm going to start by moving all my like terms to one side. So I have 14x and 13x on either side. I'm going to subtract my 13x from both sides. And I'm left with just 1x equals 10. In my last example, I'm going to start by shading again. In here, I'm going to take note of these two angles. And what stands out is that one is in the shaded region and one is not. When this happens, we want to look for the position. They're still in different intersections. My car, my 122 degree car, is in the bottom right, and my x plus 130 is also in the bottom right, which means that these are corresponding angles. Corresponding angles are congruent. So when I set up my equation, I'm going to set these two expressions equal to each other. I'm going to move my like terms to the same side, so I'm going to be moving my constant, and I'm left with x is equal to -8.